Hello, and welcome to our series of vodcasts about the mole. This is Miss Carr, and I'll be leading you through the various notes that we need to take at home while you are listening to these vodcasts. Today, we're going to start with the introduction to the mole, basically what the mole is and why we care about it in chemistry. First of all, you might have some preconceived conceptions of the mole, like it's something on scary, ugly ladies' faces, or it's even something prettier on a prettier woman's face. That's Marilyn Monroe and her, characteristic mole there. Or you might even think of the biology related people of us are going to think of the animal, the mole. But the mole in chemistry is something completely different. And it's a name that represents a number, and I want you to think of other names that we know of that represent numbers that come to mind. And the first that generally comes to mind is when you think of a set of eggs. We call that a dozen eggs. And we call it a dozen because there's 12 of them. So the word dozen simply means 12. And another example would be a ream. A ream of paper, for example, and you might not know this if you're not a teacher, but a ream of paper is 500 sheets of paper. It's one of those small packs of paper inside of the box. And a gross of something is actually a dozen dozens. That's 144 of something. So if you see the word gross, you know that means it's 144 of those things. So you can buy pencils by the gross, for example. So these are all just names that represent numbers, and the mole is just like that. The mole represents a number. So the chemist mole was actually defined by this guy here. His name is Amadeo Avogadro, and he laid the foundation that later led to the development of the mole concept. And so for that reason, we call the mole Avogadro's number. Okay, and Avogadro's number is 1 mole, and it is 6.02 times 10 to the 23rd particles. So this will always be the same. A mole is a mole is a mole. 6.02 times 10 to the 23rd. It's just like saying a dozen, only it's a much, much larger number than a dozen. It's an incredibly large number. And to give you an idea of what kind of number that is. Again, you might want to take a moment to write this down, because this is a number that you need to have memorized. You need to know this number probably more than anything else in this coming unit. Over the next 2 weeks, you're going to be using this number again and again. Okay. So the chemist mole, I want to talk about a little bit about how big it is. And so I'm going to give you an example. So if I made you a millionaire and gave you a mole of dollars, and you spent $1 billion every second, so $1 billion every second, how long would it take you to go broke? So if we look at having 1 mole of dollars, okay, and then we use our dimensional analysis to say that you're spending $1 billion, that's 1 times 10 to the ninth, and you're going to spend that every 1 second. Okay, and that one second, and that 1 second is related to 60 seconds is 1 minute, and we relate that to 60 minutes being an hour, and we relate 24 hours to being 1 day. And again, you are going to need to brush up on your dimensional analysis to do these kinds of problems. So here's a perfect opportunity for you to do that. Okay, then we have 365 days in 1 year. And we have 80 years in a lifetime, essentially. That means that it would take 238,616 lifetimes to spend a mole of dollars. So that should give you some kind of idea of how much a mole is, or how much money a mole of money would be. So if you were to spend $1 billion every second, it would take you 238,000 lifetimes to spend that money. So another example of how much is a mole is, would Cowboy Stadium hold a mole of sand? So if we take a look at how much sand weighs, or how much volume, and how much space it takes up, we have 5 times 10 to the negative 6 square or cubic centimeters to be the volume of 1 grain of sand. And then we have Cowboy Stadium has a volume of 2,900,000 cubic meters. So using those two volumes, we can take a look and see first our volume of a grain of sand, and we want a mole of sand, so we're going to multiply those two numbers. So we have 3.01 times 10 to the 18th cubic centimeters. That's 1 mole of sand. So then we would have, that would be the volume of a mole of sand. So we need to convert the cubic centimeters, of course, into meters, because our Cowboy Stadium having a volume of meters cubed as opposed to our centimeters cubed. So we need to make sure that we get it into the right units. And then we have the volume of Cowboy Stadium in cubic meters equals 1 Cowboy Stadium. That means that it would take 1,038,000 Cowboy stadiums to house 1 mole of sand. And that's quite a few Cowboy stadiums. That's a few more than one. So we could fill all of these Cowboy stadiums and then some, and we would still not come anywhere close to a mole of sand. So I want you guys to really think about this. Why do we have to use a number as large as a mole? When would we ever need a number that is that incredibly large? Now, that's going to be your critical thinking question of the day, and it's going to be something for you to think about. Now, you can follow this up if you're still having any difficulties or questions. You can follow it up with the second vodcast, or you can follow it up with the Colorado Boys vodcast, which I will also upload to the same link. So thank you very much for listening to our first podcast. Please answer this question in your notes and make sure you bring it to class to be checked off. Why do we have to use a number as large as the mole? Thank you very much.